The star Betelgeuse, an incredibly large red supergiant found in the heavenly gathering of Orion, has long captivated stargazers and cosmologists alike because of its sheer size and brightness. Assuming Betelgeuse were placed where our Sun is, it would expand to the orbit of Jupiter, demonstrating its immense size despite being located around 642 light-years away. Because of its enormous size, Betelgeuse is potentially one of the most awe-inspiring stars visible to the unaided eye. Actually, Betelgeuse has shown odd behavior, such as surprising dimming and brightening cycles, which various investigators believe signal that the star is nearing the end of its life. The notable physicist Brian Cox recently made a remarkable statement that Betelgeuse is on the verge of a stunning event expected to occur within the next 14 days. This event, known as a supernova explosion, will mark the end of Betelgeuse's life. However, it will provide a unique opportunity for researchers to study one of the most mysterious and powerful stellar phenomena in the universe. As a red supergiant, Betelgeuse is one of the largest and most massive types of stars. It has been observed by astronomers for centuries, but its recent unpredictable variations have sparked theories that it is preparing for a massive explosion. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, triggering a tremendous explosion that releases an immense amount of energy, radiation, and material into space. Betelgeuse's forthcoming explosion is expected to be a Type II supernova, a specific type of stellar event that occurs when the core of a massive star collapses. This collapse triggers the release of neutrinos and radiation, creating a shockwave that obliterates the star. The explosion will be so bright that it may be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. Typically, such an event would be catastrophic if it occurred near Earth. However, at a distance of approximately 642 light-years, this explosion, while dramatic and spectacular, poses no threat to life on our planet. Nonetheless, the event promises to transform our understanding of supernovas and other cosmic phenomena. A supernova explosion is one of the most powerful events in the universe, releasing more energy in a fraction of a second than the Sun will emit in its entire lifetime. Betelgeuse's explosion will not only be an incredible cosmic display but also a groundbreaking moment for science. Researchers are eager to observe this extraordinary event from its earliest moments using an array of ground-based and space telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, in an effort to collect as much data as possible. When Betelgeuse explodes, it will release a wide range of radiation, from visible light to gamma rays. One of the most important aspects of this supernova will be the flood of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion, due to their ability to pass through almost everything unhindered. Observatories like Japan's Superkamiokande, IceCube in Antarctica, and Canada's Sudbury Neutrino Observatory are preparing to detect these neutrinos, providing an early advantage in tracking Betelgeuse's final moments. The explosion will also provide valuable insights into the formation of heavy elements. When stars explode, they create and scatter elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will offer researchers a clearer understanding of how these elements are produced and dispersed, contributing to our knowledge of planet formation and cosmic chemistry. While Betelgeuse's explosion is unlikely to harm Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst, particularly the emission of cosmic rays and charged particles, could lead to stronger auroras, extending the regions where the northern and southern lights are visible. While these powerful rays could temporarily disrupt satellite communications and some Earth-based technologies, the effects are expected to be minor and short-lived. Perhaps one of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. If Betelgeuse remains visible for several months or longer, it will likely become the brightest object in the night sky, possibly even visible during the day. This event will thrill amateur and professional astronomers alike, sparking a renewed public interest in space science and the mysteries of the universe. Scientists have long speculated about Betelgeuse's fate, but Brian Cox's recent statement has added a sense of urgency to the matter. Observatories worldwide are preparing to monitor every phase of the supernova, and the data gathered will be crucial, potentially revolutionizing our understanding of stellar evolution, cosmic explosions, and the distribution of heavy elements throughout the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Since it is relatively close to Earth, it offers a unique opportunity to study how energy from such an explosion propagates through space. By analyzing the light and radiation from the supernova in relation to the interstellar medium, cosmologists will gain a clearer understanding of the size and structure of the universe. This event will also provide a rare chance to study dark matter and its influence on the universe. Dark matter, the mysterious substance that makes up around 85% of the universe's mass, does not emit or absorb light, making it incredibly difficult to detect. However, observing how light and matter interact around Betelgeuse after its explosion could provide clues about the role of dark matter in shaping cosmic structures. Betelgeuse's explosion will also deepen our understanding of the life cycles of stars, particularly how supernovas contribute to the formation of essential elements for life. Supernovas play a crucial role in distributing carbon, oxygen, and other fundamental building blocks throughout the cosmos, materials that eventually form new stars, planets, and even life itself. The social and cultural impact of Betelgeuse's explosion will also be profound. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of Orion's most famous stars will prompt philosophical reflection on the impermanence of the universe. In some cultures, such cosmic events have been interpreted as omens of great change. Betelgeuse's explosion may inspire a mixture of awe, fear, and wonder, as people from all walks of life witness the death of a star. This historic event will likely reignite interest in space exploration and stargazing, uniting amateur and professional astronomers worldwide as they document this once-in-a-lifetime cosmic phenomenon from their unique vantage points. Betelgeuse's supernova is not just a spectacle, it is a stepping stone for future research. The data gathered from this explosion will shape how we study other stars and supernovas, particularly as humanity looks toward interstellar exploration. This event is expected to be one of the most significant cosmic occurrences in recent history, providing an unparalleled scientific opportunity. The world will be watching as Betelgeuse's final moments unfold, marking one of the most extraordinary astronomical events of the modern era. The anticipation surrounding this event highlights humanity's deep curiosity about the cosmos and our relentless pursuit of knowledge. The scientific goldmine of Betelgeuse's supernova. Once Betelgeuse explodes, it will release a tremendous amount of energy and matter, providing scientists with critical insights into the physics of stellar deaths. Researchers will focus on several key areas. 1. The explosion mechanism. Observing the precise way Betelgeuse collapses will help astronomers refine their models of supernova mechanics. 2. Neutrino emissions. As one of the earliest signals of the event, the detection of neutrinos will allow physicists to probe the core collapse in unprecedented detail. 3. Element formation. The ejected materials, including heavy elements like iron, gold, and uranium, will offer valuable data on how supernovas enrich the cosmos. 4. Supernova remnant formation. As the explosion settles, astronomers will study the remaining nebula, which could evolve into a pulsar or black hole. A new era for supernova detection. While Betelgeuse's explosion will be visible to the naked eye, modern technology allows telescopes and satellites to capture it across multiple wavelengths: radio, infrared, visible light, ultraviolet, X-ray, and gamma rays. Space telescopes like Hubble, James Webb, and Chandra X-ray Observatory will examine the shockwaves and energy output, while ground-based observatories will track the light curve and expanding debris cloud. Meanwhile, AI-driven astronomical surveys, such as Vera C. Rubin Observatory's Legacy Survey of Space and Time, LSST, will help astronomers compare Betelgeuse's explosion to other known supernovae, refining predictive models for future stellar deaths. Could this impact Earth? At 642 light-years away, Betelgeuse's supernova is far enough that its radiation won't pose a threat. However, scientists expect some cosmic side effects. A surge in cosmic rays, which may temporarily affect Earth's magnetosphere and ionosphere, possibly altering radio communications and satellite operations. An increase in auroras, potentially making northern and southern lights visible at lower latitudes. A boost in high-energy astrophysics, as researchers track the impact of the explosion's gamma-ray burst and neutrino wave. The cultural impact of Betelgeuse's explosion. For millennia, civilizations have looked to the constellations for guidance, mythology, and inspiration. The sudden disappearance of Betelgeuse from Orion will be a once-in-a-lifetime event, stirring reactions across scientific, philosophical, and cultural domains. Historically, bright supernovas have been recorded by ancient astronomers, such as the Chinese and Arabic scholars who observed the 1054 AD supernova, which left behind the Crab Nebula. This new event may inspire a similar wave of excitement, wonder, and even superstition. Religious and spiritual groups may interpret Betelgeuse's explosion as a symbolic event, reinforcing beliefs about the transience of life and the vastness of the cosmos. Meanwhile, science communicators and educators will seize the moment to ignite public curiosity about astronomy and the mysteries of deep space. A future shaped by Betelgeuse's death. In the long term, Betelgeuse's explosion will deepen our knowledge of stellar life cycles and cosmic evolution. Astronomers will use this event to improve predictive models for when other red supergiants, like Antares and Scorpius, might explode. Fine-tune the Hubble constant, which measures the expansion rate of the universe, by analyzing the light echoes from Betelgeuse's supernova. Enhance space travel technology, as understanding supernovae will be crucial for future interstellar missions. The ultimate cosmic spectacle. 4 weeks or months, Betelgeuse's explosion will dominate the night sky, shining as a beacon of scientific discovery and cosmic wonder. The event will bring together astronomers, researchers, and the general public in a shared experience, watching the final moments of a dying star unfold in real time. Though Betelgeuse's demise marks the end of one celestial giant, it will also symbolize the ongoing cycle of cosmic renewal, where new stars, planets, and potentially life itself will emerge from the ashes of destruction. A final thought. As we look up at Orion, waiting for the inevitable flash of Betelgeuse's final farewell, we are reminded of our place in the vast, ever-changing universe. The universe is a place of creation, destruction, and rebirth, and now, we stand on the verge of witnessing one of its most magnificent transformations. Inspiring. As Betelgeuse approaches the last phase of its life, one of the more speculative yet dazzling possible outcomes connected to its looming explosion is providing insight into some of the deepest secrets of the universe, matter and dark energy. These two forces are believed to account for most of the universe's mass and energy, but they remain unclear. According to some theories, supernovas like the one predicted from Betelgeuse could hold the key to gaining access to some of these mysteries. Supernovas release enormous amounts of energy and radiation, and some researchers believe these powerful forces might interact with dark matter in ways that we can study and observe. An interesting hypothesis is that dark matter exists as faintly interacting massive particles known as WIMPs, weakly interacting massive particles. If WIMPs exist, the energy interactions produced by the cosmic Betelgeuse explosion could reveal information about their nature. Such a discovery would be groundbreaking, providing the first tangible evidence of dark matter, a mysterious phenomenon that has puzzled scientists for decades. Moreover, there is potential for Betelgeuse's blast to offer insight into the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. Understanding its role in cosmic evolution is one of the greatest challenges in modern physics. An explosion of Betelgeuse could provide indirect evidence of dark energy's impact on stellar death, as it is believed that supernovae are influenced by the universe's expansion. Observing how Betelgeuse's cosmic explosion propagates throughout space may provide vital information to help scientists understand how dark energy affects massive events and shapes the universe's large-scale structure. As Betelgeuse's cosmic explosion gets closer, cosmologists are preparing for one of the most anticipated cosmic events of the century. The blast will provide a unique opportunity to observe the final stages of a massive star, offering information that could have an impact far beyond our current understanding of stellar life cycles. As researchers anticipate the dramatic display of the cosmic explosion, they are also refining techniques to study its aftermath. One area of focus is the formation of a neutron star or possibly a black hole in the remnants of Betelgeuse. A neutron star is the dense core left behind after a massive star like Betelgeuse undergoes a supernova explosion. These compact objects, which can have a mass greater than the Sun packed into a volume no larger than a city, are a key area of focus in cosmology. If Betelgeuse forms a neutron star, it will offer a one-of-a-kind opportunity to study the behavior of matter under extreme conditions. Neutron stars are also known to produce extremely strong magnetic fields and are sometimes observed as pulsars, emitting regular bursts of light. The formation of such a celestial remnant could offer crucial insights into fundamental physics, extreme gravity, and the behavior of matter at extremely high densities. If Betelgeuse collapses into a black hole instead, it will be another major breakthrough for scientists studying the formation of these mysterious objects. Black holes, regions of space where gravity is so strong that not even light can escape, have been the subject of fascination and theoretical research for many years. Observing the formation of a black hole from a relatively nearby star like Betelgeuse will help scientists refine their models of black hole formation and better understand their role in the universe. It could also provide new ways to observe the event horizon, the limit beyond which nothing, not even light, can escape, offering further insights into the nature of black holes. Another important factor is how Betelgeuse's explosion will contribute to our understanding of cosmic rays. These high-energy particles, produced in events like supernovas, can travel vast distances across the universe. While some cosmic rays are detected by observatories on Earth, others have been difficult to study due to their erratic nature. When Betelgeuse's cosmic explosion occurs, it will produce a huge amount of high-energy particles, providing researchers with an opportunity to examine cosmic rays in real time. This could enhance our understanding of how cosmic rays interact with the interstellar medium and what implications they might have for space travel and technological systems on Earth. As Betelgeuse's anticipated explosion draws near, the scientific community is preparing for an event that will provide an unparalleled opportunity to study a star's death and its aftermath in real time. While supernovae are not rare in the universe, Betelgeuse's proximity to Earth offers a one-of-a-kind chance to observe this cosmic event with unprecedented detail. The data gathered could significantly improve our understanding of stellar life cycles, the process of star formation, and how supernova explosions contribute to the larger cosmic ecosystem. One of the most exciting possibilities lies in the study of the interstellar medium. The explosion of Betelgeuse will release a significant amount of gas and dust into space, which will interact with the surrounding materials in the Orion constellation. Researchers will closely monitor how these elements spread across the galaxy and interact with existing star systems. These materials, some of which include elements like hydrogen and heavier ones like iron, will be crucial in forming new stars and planetary systems. The ejected material will serve as a cosmic seed, contributing to the ongoing cycle of stellar birth and death. Additionally, the explosion will have important implications for our understanding of spacetime and gravity. As the remnants of Betelgeuse either form a neutron star or collapse into a black hole, scientists will observe how these dense objects warp spacetime in real time. Neutron stars, with their immense gravitational fields, are known to bend light and time. If a black hole forms, it will present an opportunity to study the warping of spacetime near its event horizon, offering additional insights into Einstein's theory of general relativity. This event will also be a catalyst for new technological advancements. The vast amounts of data gathered from the explosion will be analyzed using cutting-edge computational techniques and artificial intelligence. This will not only improve our understanding of the universe but also push the boundaries of data science, allowing astronomers and physicists to process and interpret enormous datasets in ways never before possible. Beyond the immediate astronomical significance, the explosion of Betelgeuse could also provide valuable data for planetary defense and space exploration. Supernovae generate intense bursts of radiation, including gamma rays and cosmic rays, which can impact planets and their atmospheres. By studying how these high-energy particles interact with the interstellar medium, scientists can refine models predicting how similar cosmic events might affect Earth and other planets. Additionally, the study of Betelgeuse's explosion could contribute to our understanding of exoplanet habitability. If a supernova occurs near an exoplanet, it could strip away its atmosphere, dramatically altering conditions for potential life. By observing Betelgeuse's explosion in detail, researchers may gain insights into how stellar deaths influence the development and sustainability of life in different parts of the galaxy. Another area of interest is the role that supernovae play in galactic evolution. The explosion of a massive star like Betelgeuse releases enormous amounts of energy and material, enriching the interstellar medium with heavy elements such as carbon, oxygen, and iron. These elements are essential building blocks for new stars, planets, and even life itself. By analyzing the dispersal patterns of Betelgeuse's ejected material, scientists will gain a better understanding of how supernovae contribute to the chemical evolution of galaxies. This could offer deeper insights into the life cycles of stars and the formation of planetary systems, including our own solar system, which was shaped by the remnants of ancient stellar explosions. Moreover, the event could improve our knowledge of gravitational waves, ripples in spacetime caused by the acceleration of massive objects. If Betelgeuse's core collapse leads to the formation of a neutron star or black hole, it may generate detectable gravitational waves. Advanced observatories such as LIGO, Laser Interferometer Gravitational Wave Observatory, and Virgo will be on high alert, aiming to capture any gravitational signals produced by the explosion. Detecting gravitational waves from a nearby supernova would be a monumental achievement, allowing physicists to study the internal mechanics of a collapsing star in real time. It could also provide crucial data for testing and refining Einstein's general theory of relativity, further advancing our understanding of gravity on cosmic scales. In addition to its scientific implications, Betelgeuse's explosion will captivate the general public, offering a rare celestial spectacle visible from Earth. The supernova is expected to shine as bright as the full moon for weeks or even months, making it a once-in-a-lifetime event for skywatchers. Astronomers, educators, and science communicators are preparing for this moment, ensuring that people around the world can witness and understand the significance of Betelgeuse's transformation. Public outreach efforts, including online live streams, interactive simulations, and educational programs, will play a key role in engaging audiences and inspiring future generations of scientists. As we await the cosmic fireworks, one thing is certain: Betelgeuse's explosion will mark a new chapter in our exploration of the universe. Whether it helps uncover the mysteries of dark matter, reveals new insights into stellar evolution, or simply leaves us in awe of the cosmos, this event will be remembered as one of the most extraordinary astronomical phenomena of our time.